The pressure due to a column of liquid depends on the weight of the liquid in the column. So remember that pressure is caused by the weight of the water above. So pressure is equal to the height of the column multiplied by the density of the liquid multiplied by the gravitational field strength. Density is the mass per unit volume, so it's a measure of how heavy a substance is for the quantity measured. Gravitational field strength is defined as the gravitational force in newtons that acts on a mass of 1 kilogram. So it's the weight per unit mass. Now this equation only calculates the pressure from the liquid above. It does not consider the upthrust from below. In symbol form, the equation becomes P equals H times by rho times by G. So we know that the pressure is equal to force divided by area. So this equation can be derived using the equation for weight and then dividing by the area. We just use the volume and density to find the mass in this case. The pressure is measured in pascals. The height of the column is measured in meters. The density of the liquid is measured in kilograms per meter cubed, and the gravitational field strength is measured in newtons per kilogram. Normally, the gravitational field strength changes with depth, which would require a different equation, but you can assume that this is the equation to use for pressure depth problems in an exam. Let's have a look at an example. A diver practices swimming at the bottom of a diving tank and experiences a total pressure of 296 kilopascals from both the water and the air above. The density of water in the tank is 1,000 kilograms per meter cubed, and the pressure from the air above is 100 kilopascals. Calculate the depth the diver is swimming at to experience this pressure. So we have to consider the pressure from the air, as the air is pushing down on the water, which transfers a force to the diver. So the air above is at a pressure of 1 atmosphere. So for step 1, let's calculate the pressure from only the water. So the water pressure is equal to the total pressure minus the atmospheric pressure. So the water pressure is equal to 296 kilopascals minus 100 kilopascals. We don't need to convert the units here as we're subtracting the same unit. So the water pressure is equal to 196 kilopascals. For step 2, let's list the key information and check the units. The pressure is equal to 196 kilopascals, which is equal to 196,000 pascals. The density is equal to 1,000 kilograms per meter cubed. And the field strength is 9.8 newtons per kilogram. And we want to find the height of the column, as the diver is at the bottom of the column, so the height of the column has the same meaning as the depth in this example. For step 3, let's rearrange the depth equation to make height the subject. So we can do this by dividing both sides of the pressure equation by density and also by the gravitational field strength. The equation then becomes pressure divided by the density multiplied by the field strength is equal to the height. For step 4, let's substitute the values into the rearranged equation. So here we've simply flipped the equation we found in the previous step, so we have the height of the column is equal to the pressure, all divided by the density of the liquid multiplied by the gravitational field strength. So the height is equal to 196,000 divided by 1,000 multiplied by 9.8. So the height of the column is 20 metres.
Thanks for watching. If you want to take your GCSE revision to the next level, head over to launchpadlearning.com and check out our smart learning platform that's been designed to get you top results in your exams. We cover your whole specification and make revision fun with interactive quizzes, easy-to-follow videos, and more. You'll be kept motivated by your own AI tutor who's here to support you every step of the way. To check it out for yourself, click here. or click here to keep watching a selection of the videos from our full GCSE Physics course. See you there!